Welcome to today's explainer. All right, I want you to go ahead and strap in because this isn't just your standard everyday overview of the planets. No, consider this a high-stakes mission briefing. We're going to look at exactly what it takes to survive the ultimate tour of our solar system. Think about it. If you were a future astronaut attempting to touch down on every single planet in our cosmic neighborhood, what exactly would be waiting for you out there? We're going to visualize the extreme environments, the toxic atmospheres, and the literal mind-bending pressures that define our cosmic backyard. Okay, let's dive into this. Our flight path today is moving chronologically outward from the sun. We're starting with this mission briefing, then we'll fly straight into the inner inferno of Mercury and Venus. From there, it's on to the red hope of Mars, navigating the gas giant's gauntlet, plunging into the outer ice abyss of Uranus and Neptune. And then we'll wrap the whole thing up with a final debrief. So, let's begin our planetary descent. I really want to frame this explainer as a personal challenge to you. Could you actually survive this tour? We're actively looking for the absolute most dangerous planetary threats. You know, we tend to look up at the night sky and just see these peaceful, twinkling little dots. But up close, these planets are violent, they're chaotic, and they are relentlessly hostile to human life. Surviving out there completely depends on understanding the specific, unique dangers of every single world.
Right, so our first stop takes us to Section 1, the Inner Inferno, covering Mercury and Venus.
As a future astronaut heading this dangerously close to the sun, consider this your highest level warning. You are about to face an absolute nightmare of extreme heat and relentless solar radiation. Let's look at Mercury first. What's truly terrifying here is the sheer violent contrast. It's the closest planet to the sun, but it actually lacks a proper atmosphere to regulate its temperature. It's only got this incredibly thin exosphere. Because of that, daytime temperatures skyrocket to 430 degrees Celsius, while the nighttime side completely plummets to an icy minus 180 degrees. For some context, the absolute latest NASA spacesuits can only handle a range between 121 degrees and minus 157 degrees Celsius. That means on the day side, you're burning up, and on the night side, you're freezing solid. Plus, you're getting almost 7 times the solar radiance we get here on Earth. So your literally only hope for survival is a precision landing in what we call the Terminator Zone, that tiny, thin strip between day and night where temperatures are actually somewhat manageable. Moving on, we fly just 40 million kilometers away from Earth. That's a relatively short 4-month journey to Venus. Now, the gravity here is very Earth-like, which sounds great, right? But look at what actually welcomes you. These beautiful yellow clouds? Yeah, they're actually made of highly corrosive sulfuric acid that would destroy your lungs in seconds. And hey, even if you had a suit to filter that out, the carbon dioxide atmosphere is so unbelievably thick that only 10% of sunlight even makes it to the surface. You would be standing in pitch black darkness, just baking in an unbearable surface heat of 450 degrees Celsius.
And that brings us to this incredibly terrifying number, 92. This is the atmospheric pressure right on the surface of Venus. To put that into perspective for you, Earth's pressure at sea level is just 1 bar. Venus is 92 bars. So even with that Earth-like gravity we talked about, the air here is so impossibly dense, it would literally feel like you were wading through a heavy liquid. Even if you were wearing a highly advanced pressurized spacesuit, you might last, a few seconds before the sheer crushing weight of the atmosphere collapses your suit entirely.
Leaving the crushing depths of Venus, we arrive at Section 2, the Red Hope, focusing on Mars. So we're going to shift our tone a bit as we look at Mars, which is pretty widely considered the most habitable rock on our tour. I mean, on a good day at the equator, temperatures can actually hit a relatively comfortable 20 degrees Celsius. Sounds almost like a nice spring day on Earth, right? But definitely don't let that fool you. If you're setting up camp on Mars, you have got to rigorously check this life support list. Mars is full of silent killers. The atmosphere is extremely thin, and it's made mostly of unbreathable carbon dioxide. Nighttime temperatures, they can easily drop to a freezing minus 13 degrees Celsius. And then there's the weather. You have to anchor everything down because Mars experiences incredibly violent dust storms, with wind speeds whipping up to 100 kilometers per hour. You absolutely need an airtight, well-insulated habitat just to protect against these extremes. But actually, there's an even more deadly, completely invisible threat waiting for you. That invisible threat is radiation, and the number you really need to remember here is 50. Because of that super thin atmosphere we just talked about, the average natural radiation level on Mars is 24 to 30 rads. That is 40 to 50 times the average radiation exposure you're getting right here, right now on Earth.
Just taking a walk on the surface without heavy, dedicated radiation shielding would be an instant, fatal error for any astronaut. Okay, leaving the rocky worlds behind, we arrive at Section 3, the gas giant's gauntlet, focusing on Jupiter and Saturn. As we approach Jupiter and Saturn, your survival tactics have to change completely. We're no longer worrying about landing on solid ground. Nope. Instead, we are battling immense gravity, mind-boggling radiation, and crushing atmospheric depths. And this brilliantly illustrates the lethal extremes of both of these massive planets. On Jupiter, you are dealing with winds hitting 482 kilometers per hour and a core temperature of 24,000 degrees Celsius. Plus, Jupiter's gravity is 2.4 times stronger than Earth's. It pulls you down incredibly fast, all while bombarding you with extreme radiation that could literally kill you from 300,000 kilometers away. Saturn, on the other hand, it dials the wind up to a staggering 1,800 kilometers per hour. Its core is slightly cooler at 11,700 degrees, but it presents a totally unique navigational hazard. 146 orbiting moons and dense rings made of ice pellets, comets, and old space debris that you have to somehow dodge just to get inside.
Let's just imagine for a second that you actually drop into Jupiter. This is your descent protocol. First, you fall through these thick, white clouds of frozen ammonia crystals at a bitter minus 150 degrees Celsius. If you make it 150 kilometers down, which, by the way, is exactly the depth NASA's Galileo probe reached before failing back in 1995, it gets completely dark. The pressure skyrockets. Eventually, you enter this bizarre layer of supercritical fluid, where you're essentially swimming in a state of matter that is neither fully a gas nor liquid. It's just strange. Go even deeper, and you hit extremely dense liquid metallic hydrogen. Finally, if you somehow survived pressure that is estimated to be 100 million times what we feel on Earth, you'd reach the core, roasting at 24,000 degrees Celsius. That is roughly 4.5 times hotter than the surface of our own sun. Absolutely wild.
Now, if you opt to drop into Saturn instead, you might initially be captivated by these incredible red and purple auras at the equator. But if you head up to the North Pole, you're gonna face this anomaly. A massive, swirling storm so unimaginably huge that you could literally fit 2 whole Earths right inside of it. You'd be plunging straight through minus 250 degrees Celsius ammonia clouds, eventually hitting pressures comparable to the absolute deepest trenches of Earth's oceans, before the gases transition to liquid and you smack into that molten rocky core. If you've somehow survived this far, the pacing of our journey really slows down to an eerie crawl. Welcome to Section 4, the Outer Ice Abyss, Uranus and Neptune. Before we dive headfirst into Uranus and Neptune, we really need to clarify what an ice giant actually is, because the term is a little bit misleading. It does not mean these planets are just solid, giant balls of ice that you could nicely land your ship on. Nope. Instead, it means their composition is primarily made up of elements heavier than hydrogen and helium. The reality is, if you tried to land here, you wouldn't crash into a frozen surface at all. You just fall endlessly through these dense, toxic, freezing layers of gas and slush. Take a look at this timeline of a hypothetical free fall into Uranus. First off, keep in mind Uranus spins entirely on its side, which makes for a completely bizarre environment with a really fast 17-hour day. At T-0, you've got to dodge its ring system. By minute 1, you're totally surrounded by toxic gas in the coldest environment in the entire solar system, dropping well below minus 200 degrees Celsius. By minute 10, the atmosphere gets dangerously dense, just pelting your ship with high-speed ice pellets. And by minute 30, well, you encounter one of the most spectacular yet totally lethal phenomena in all of space. It literally rains solid diamonds, and they're being driven by 900 km/h winds under pressure 100 times greater than what we feel on Earth. Finally, we reach the very edge of the planetary tour, Neptune, the supersonic twin to Uranus. Neptune sits a staggering 30 times farther from the sun than Earth does. It is incredibly dark and absolutely freezing on the outside. But inside, that's a different story. The intense pressure creates a core that sits at 7,000 degrees Celsius, which, again, is hotter than the surface of the sun. This intense heat and pressure literally break down methane in the atmosphere to forge that spectacular diamond rain we just talked about. And while you're falling through all of this, you would be battered by the absolute strongest winds in the solar system, reaching literal supersonic speeds.
While we've made it through the fire, the acid, the intense radiation, and the supersonic diamond rain, let's head into Section 5, Final Debrief, and Survival Assessment. So the crucial point is this. Surviving a grand tour of the solar system requires practically indestructible technology. From the 92-bar crushing weight of Venus to the 24,000-degree core of Jupiter, every single planet out there has a unique, beautifully terrifying way to end a mission instantly.
Which really brings us to our final thought for today. Earth is our only true safe harbor in a deeply hostile solar system. When you map out the lethal radiation and the crushing pressures of our neighboring planets, you start to realize just how incredibly fragile our existence here truly is. So if humanity does eventually push outward into the dark, the question remains, which of these deadly gauntlets will we dare to conquer first? Thank you so much for joining me on this mission briefing today. Keep looking up, stay curious, and I'll catch you in the next explainer.